Hi, everyone. Told you we'd be doing some Facebook Live updates. This is during a commercial break. If you're watching the national championship so far, Indiana has the lead, but I think Miami is driving. And I don't know if you saw that hit that Mendoza took in the face, man. It was pretty impressive. So, well, let's talk about it. First of all, I want to cut to the chase and talk about the Northern Lights. So, yes, we experienced quite a significant solar storm. In fact, the coronal mass ejection, which is a plasma cloud that's shot out from the sun from an explosion called a solar flare, and you got all this charged particles that are headed towards the Earth. They hit the Earth, and this thing was moving really quick. But there's a problem. The problem is that the magnets aren't connecting. So we've got a positive pointing, or a positive field, if you will, a northward field of the charged particles, and there's a northward pointing field for the Earth's magnetosphere. So those two didn't connect. I can show you what I mean here if we take a look here at some magnets. First of all, though, I want to show you a couple of things. Number one, we're going to take a look at the winter system that's coming our way, and we're also going to take a look here at the Northern Lights potential. But first of all, we'll break down the Northern Lights potential. So why are we seeing the potential for Northern Lights? It's all because of this. This is a solar flare that exploded basically yesterday afternoon. Now, typically these take about 2 days to reach the Earth. This one reached the Earth in just over 24 hours. So really, really fast. In fact, when we look at the speed of this, it was actually as fast as some of the top few percents in terms of the speed for the coronal mass ejection. So we're talking a really, really fast charged particle cloud that made it towards the Earth. We can actually see this explosion, and it's what's called a full halo CME. So if we look at spaceweather.com, this is the website right here, and this is the explosion of those charged particles that are headed towards the Earth. They already hit, but here's the problem. We had a solar storm, and the Northern Lights have been able to be seen in the eastern United States and really crazily cranked up over areas of Italy and basically Europe. Europe saw a really impressive show. And look at this. I've got Callie Girl on here. So thank you so much, Callie, for joining the conversation. I do know Indiana's winning. Are you actually watching that at home? Anyways, we'll talk about the Northern Lights. Does that mean we're going to get the northern snow? I'll take the lights instead. We'll talk about the snow in just a bit. Let me break down one thing at a time. But here's what we need. We need the BZ to go negative, and I'll show you what I mean. We're going to bring this website up. We're going to go to what you can do is you can go to spaceweather.com, or you can go to the Space Weather Prediction Center. But we're going to click on this. This is called Discover. And Discover is essentially measuring what's happening with the Earth's basically the real-time solar wind. So when did all the Northern Lights go nuts in the Europe area and Italy? This is all right here when that BZ was extremely negative. So when this thing first hit, yeah, it was big time negative, and 57 BZ negative is pretty impressive. However, notice how it flipped. And what I mean by that is, again, I'm going to show you with the cursor. We'll zoom in on this, but when the BZ flipped right here, you can see that it's all positive. It's above this solid gray line. When it's above that solid gray line, that just does not connect with the Earth's magnetic field. So you'll notice how it's slowly dropping and actually subsiding. The solar wind is actually not represented properly due to the contamination of the charged particles, from what I learned from solar scientists. But in order to see the Northern Lights, this has to flip and go negative. So yes, we got blasted by the CME. It was really fast. The solar wind, look at how fast it sped up. It went from basically very, very slow to just a little over, it looks like 290 kilometers per second. Instantly hit. That is definitely the coronal mass ejection hitting. And at first, it went big time negative, but then it just immediately flipped and went positive. So how do you attribute that? that right there is just not going to be a favorable northern lights show for us, at least to see with the naked eye. Now, there is a chance that we get some type of solar substorm that develops, and what that would do is that would create essentially a flip in the magnetic field. But let me show you this real quick. So I've got some magnets right here, and I just want to kind of illustrate how this works. So the Earth's magnetic field is like a magnet, and we have the coronal mass ejection that's coming. And if I essentially have one magnet that's coming and they're going to repel, they're never going to stick together. But if you hear that click, that's where you have the magnetic field that sticks. So if I'm this way, guess what? It's not going to click. It's just going to fall. That's what's happening. We have two positive fields, and that just doesn't lead to the northern lights. So that kind of covers that. If you want to watch and see if the northern lights potential happen, and you might be able to see it with the camera. That's right, around 7:30. So we still have that BZ positive, but it's not creating a G4 or a G5 geomagnetic storm. We're at a G2 right now. And the KP index has dropped to a 7. It used to be an 8, almost a 9. It got up to about 8 I think it was like 8.7 or 8.8. It was up there. It was way up there, but now it's dropped down. But there's still that potential maybe to see with your cameras faintly. We can look at some of our WeatherBug network cameras, and remember the November 11th show. Oh, man, did we have a show. But right now, we're maybe seeing, no, you're not really seeing it. Even the camera's not picking it up. So there's still a potential. You might be able to see maybe a little bit of a hue off in the distance, but the sky definitely cleared. All right, let's talk about what you want to know about the winter weather potential. And so we do have the potential for winter weather, but there are a lot of uncertainties. There still are. So it looks like Indiana scored a touchdown, but it looks like it was turned down and overruled. So no lights for us. Yeah, we're talking about that. So I thought people were saying this is and the solar eclipse are once in a lifetime experience. It wouldn't happen for years apart. Well, we are in a solar cycle maximum right now called second and goal, a little short. We're in a solar maximum, solar cycle 25. It's starting to drop off from the peak of the solar cycle, but at this time we still have that potential for solar storms and northern lights. It's pretty rare, but in a solar cycle, it's not as rare. So when you're in solar maximum. So anyways, northern lights, questionable. It looked like it was going to be impressive. It was negative, but it flipped to positive. And so just like kind of how Miami could literally do a scoop and score or a pick six, and then that just totally flips everything. So very, very similar to that. Let's talk about the winter weather potential. And first of all, let me break this down for you that it is very much uncertain at this point, and for good reason. Now, I know there's social media posts about, the European is not helping matters because the European has gone bonkers with the precipitation amounts. In fact, you can see right here, some people are saying that Jeremy's saying the GFS is hardly showing anything, but the Euro is showing 18 plus inches in the river valley. You got to remember too that what the models show, it's not typically exactly what happens. There's all sorts of different factors that come into play. This is taking every single hundredth of an inch of precipitation and it immediately converts it to snow. That doesn't always happen. But let's cut to the chase. Enough of me blabbing about this. This is the weather system that's coming our way. This winter system is so far away right now. I mean, to put it into perspective, you'll notice that it's over 2,000 miles away from Oklahoma City. So first of all, there's a lot of time for this and a lot of distance for it to travel. It's a very complicated mixture of low pressure systems that are kind of churning. Now, the GFS is keeping the system off the southwestern coast. I don't necessarily believe that. So I do believe that the European is a little more correct. I do believe there's going to be a little more energy. I'm not quite sold on the heavy amounts of precipitation it does. But about some time we get some drama in the DGZ. There's my snow dog right there, John Leachman, who runs all around. And even in He'll probably still be running on Sunday morning when it's like nearly zero, and Monday morning when it's below zero, if we get that snowpack. So this is the way that the European is showing this system to evolve. All right. And then we'll take a look. I just want to give you a background history about how this storm is going to evolve and why there's uncertainty. There's big time uncertainty. There's the system. Notice how, look at how much that had to do. So you have basically two systems. One of them essentially breaks off. As it breaks off, one of them goes southeast, the other one goes northwest. Now that's important because that one to the northwest starts dropping southeast again and kicks this system out, according to some of the models. So this right here is showing Wednesday, 7 p.m. It's got it off the coast of the southwestern United States. Why is that important? Because models aren't going to handle exactly what happens with this system. Even if they have it perfectly sampled, they still won't get it perfectly right. But nevertheless, there's the system, and now here's the kicker system. Did you see it? Dropping southeast. It's the same one that went north, and then it starts dropping southeast. Now, I personally do believe this in terms of this computer model. So right here, as you'll see, is what's called the kicker system. Now, this also has a lot of energy that's to the south. We know, you know, if you watched me before, Baja Blast energy. We talk about it all the time. We talk about severe weather, Indiana touchdown. So now 10-0 Indiana. They finally punched it in, so they scored. There's a look at the winter storm potential that's coming this way, and look at all that energy. Now, I can tell you this. That's a lot of energy. And if we are below freezing, we're talking about a significant winter event. I'm still not sold it's all snow. But at the moment, it looks like that freezing rain potential will be across northern Louisiana and southern Arkansas. But look at all of these little disturbances. You tell me, man, that's going to create some extra lift and mesoscale processes and all that stuff. And yes, you do need to crack open a Baja Blast, especially later on in the week. These type of systems develop some pretty big dry slots. They absolutely do. However, if it's a positive tilt, number two, that means it's slower. So slower, the GFSs already can be thrown out. I just don't believe how the GFS rips this thing eastward through our area by Saturday morning. That doesn't make sense. It just doesn't flat out make sense, not with the weather pattern. So there's the European model. Let's check out the GFS, and we're going to see how this evolves. But before we do that, I want to show you the GFS. I want to show the European on the jet stream. So the jet stream, big time southwest flow, still remains southwest flow. So it is still a positively tilted trough with southwest flow, and it remains positively tilted. Now that tells me that this could be an icing event in parts of the area. I don't know who, but somewhere within our region, whether that be the mid-south or the southern plains, is going to get smacked with an ice storm. We're talking big time ice potential. Hopefully not around here. So this is the latest European model, okay? And you'll see here by Friday evening, precipitation starts moving in. Now, one of the things you got to know is that there's all that energy moving in. As of now, we're calling for precipitation starting Friday evening. This could be earlier. It could happen as early as Friday late morning, just because of all that extra energy, Baja Blast energy, that the models just don't handle. I did touch the aurora. We'll go back to it, but right now the Earth's magnetic field is not connecting with this CME because it's more two positives going together, which is repelling, and that's just not, it's still causing a solar storm. It's just not as significant. All right, back to this. So Saturday morning, now we're starting to get some big time precipitation. Notice though how that freezing area is starting to shift northward a little bit from what it was yesterday. Remember, it had snow across southern Oklahoma. And now that icing is getting a little closer. Widespread precipitation in Oklahoma, as well as western and northwestern Arkansas, southwest Missouri, southeast Kansas, icing for Dallas. And you can see the way that freezing line remains way south of us. That's south of Dallas. So This is definitely a classic textbook, massive winter potential. And then look at that. That's still snowing by Saturday night. And then finally, so already accumulating snow will definitely be ongoing. And then as we go into Sunday, we're talking finally this system starts to move out with the potential for some wraparound. But there's that dry slot that was mentioned, that dry air in the mid levels that comes in. The European is modeling that, and then obviously the system kicks out. Okay, so that is essentially the European model. Let's take a look at the GFS because the GFS paints a different picture. And a lot of people are wondering about the GFS, and I personally don't like the way that it's handling this vorticity maximum at all. So let's take a look at that on Weather One. And we could do a side by side as well. So here we go. We're going to go through time. So it's got that breaking off, very similar to what the European had. Then you can see that system. Now watch. This is where I don't understand what's going on. Okay, so Wednesday, it still has it southwest of California. But then this is where things get tricky. It doesn't get picked up or absorbed by that low pressure system. In fact, okay, now it is actually the newest one has it. But notice how it gets kicked way south. Now, personally, I'm looking at this and I will load it up so I can put some pause points in there. It just doesn't look like that makes sense meteorologically because where's the kicker system? The kicker system is nowhere close like the European. It's up here. But yet it's still already starting to shove it east. So how does that technically make sense? It really doesn't. So this is all about the speed of the system. So if we're looking here again, here's the kicker system. We'll move along in time. Now it's still kicking south. How is it kicking south? There is nothing to kick it. It's got all the energy to the north. So that doesn't make sense. Whereas the European does bring that energy farther south. Now, also, too, there's already precipitation here, and the GFS isn't handling it. We know that the GFS really sucks, if you will, pardon my language, at Baja Blast energy. It does. Now, look at that. It's still on Saturday afternoon and evening. That potential winter storm, it's still to the southwest. And at this point, there's all this energy right here. But yet it doesn't produce any precipitation because it's saying that this is dry and then it kicks it out. And look, where is that system going? Now Sunday night, it's still, even Monday morning, it's still off the coast. And then finally it starts to get kicked out, but there is no kicker system. So it doesn't make sense at all the way that that's going. And then finally it comes through and then it kind of drops almost perfectly south. So what does that do with precipitation? Well, you would guess it doesn't bode very well for anybody that's a winter storm lover. So here's what we've got for this. Here's the future track, and we'll show you on this one. This is the future track for the global forecast system, and you're going to see we've got barely anything by Friday. Remember that low is still southwest. Now, as we get into Saturday morning, we've got 5 a.m. finally starting to show snow. But look, this is, by the way, the 18Z, so it has a little more than it did at 12Z, and now it just kicks out so fast. So wait a minute here. The reason it's doing that is because it's saying that dry air is coming in and all these kicker systems are pushing out. Maybe the GFS is right. And that's why we have to be cautious with saying this is already producing 12 to 14 inches of snow. No. That's what people are showing because they're just going off of one European model. We'll look at ensembles here in just a second too. But that's not good meteorology. That's not good meteorological practice either. This is what we've got right here. So long-range forecasting, there's uncertainty. There always is. And we have to basically express that uncertainty. So pattern recognition, 7 to 10 days out. We actually knew way before that. We knew that there was pattern recognition, honestly, early last week. Southwest flow, Models weren't showing any precipitation. I'm like, I don't buy that. I think we got a system moving in. We'll be watching that closely. 5 to 7 days out. That's what we were this past weekend. We're watching the trends. Is it looking more likely or less likely? Well, now it's looking more likely to occur because all the models are showing at least some potential for winter weather. But we are just about day 4 or 5. So we're at 3 to 5 days out. And 1 to 3 days out, that's when we start giving you the forecast details. But what does some of the weather apps do, such as TWC, and the Weather Channel app? They're going 14 days out and showing accumulating snow. It bugs the scrap out of me, including like a 16-day snow forecast. Sure, maybe you'll get it right once in a while. It's like throwing darts at a wall blindfolded. You're eventually going to hit the dartboard, and maybe sometimes it'll be a bullseye, but the chances of it won't be very much likely. Now, what we can do is we can look at the GFS and we can look at the trends. And so that's exactly what we're going to do here as we take a look at the GFS. And we're going to look at what's called model trend loops. So I'm going to make this full. We're going to show this here real soon. And we're going to go to pivotal weather, and we're going to bring this up. All right, so a lot of people don't show this, and very rarely do you see it. But this is deterministic model run loop. So let me make sure that's up. It is full screen. And so you're going to see as we let's go a little bit more zoomed in, shall we? Let's go to south central United States. We're going to go to 126 hours. Okay, there's the precipitation. Let's go. Why don't we go to Sunday or Saturday afternoon, 18Z? I think this is when the bulk of the winter system is really going to impact us. Now what we're going to do is we're going to look at a model trend loop. So a model trend loop is different than a model loop. What a model trend loop is we're taking all of basically the computer model runs. Okay, stay with me here. The computer model runs for the same time. So we're basically going at 18Z, which is noon Saturday, and we're looking at all the different computer model runs at that time from when it first started showing up on the model. So take a look at the inconsistency. So here's basically the run from Saturday or Friday night 0Z. Here is Saturday 18Z. Okay, pretty similar there. I wouldn't say nothing super major. Shows some precipitation. Have an idea there might be something coming. Now, here's Saturday 18Z again, meaning Saturday at noon. And this is from the model 12Z on Saturday. Next one. Oh, where'd it go? Uh-oh, everybody's freaking out. The social media posts for big time icing in southwest Missouri. The next 6 hours later, it's gone. 6 hours later, it's still gone. Oh, hey, finally, it's back. Every 6 hours, this just shows you how much it changes. Look at this. We're 6Z Sunday, basically overnight Saturday into Sunday morning, starting to show something. Now look, Saturday 18Z. Hey, Southern Arkansas, big time sleet event, right? Freezing rain down south. And then guess what happens? Next one, yeah, still showing it. Okay, but now look at the northern trend. And look at the latest one. It still shows precipitation to the west. So positively tilted trough, going to slow down. Models are way too quick, at least the GFS is. Now let's take a look at the European model. We'll do the same exact thing. We'll look at a model trend loop, 120 hours out, Saturday. And so this is Thursday night's model run. Here's Friday nights. Here's Saturday morning. Notice nothing there. So last week, even though we're like southwest flow, there should be precipitation. Miami just missed a field goal right before halftime too. That's kind of detrimental being down 10-0. It could have been 10-3 away, one touchdown away. Now look at this. All right. So you tell me there's consistency in this. Not really. This is why the European model does kind of concern me. It goes from this to this. And this is when everybody on their keyboard started going in there and one deterministic run and then grabbed it and then shot it out and then pushed it. And then when they was like, there it is, big time snow, big time winter weather event, all because of one run. It's exhausting. It's tiring. I'm not dealing with it. There's a look at Saturday again. Now this is Sunday 18Z. And here, notice big time snow, not as big, and then less. And then look, it's still got the trends. And now look at how it actually slows down. So it's got it. You can actually see the trends. If you loop it, you can really see the trends. Too fast, starting to slow down. So already we know that we've got the potential for big icing. We know the system's slowing down a little bit. So how does that convert to winter precipitation? Well, let's look at none of this is perfect either. These models are terrible. We're going to go all the way out to 144 hours, okay? So this is taking us through Sunday 18Z, I think at the end of the snow event. Here's nothing. Here's 0.1. Here's nothing. 0.3. That's not going to get much attention. Whoa! There we go. Everybody on Facebook going bonkers, posting stuff left and right, accumulation maps, all that stuff. Hey, it still has it. Now it really goes nuts. This is where everybody started acting like Kermit, where they're like, it's like, yeah, right. Next hour, still showing a lot. So maybe the Europeans onto something. If this is the case, we've got a significant winter weather event. But look at the inconsistency. Come on, nothing, and then all of a sudden starting to show. There's still so much time for that system to evolve that we still have to wait. Let's look at the GFS's snowfall accumulation. So here's this. There you get to see right there precipitation finally showing up. Hey, Sunday 12Z showing a lot of precipitation, showing a lot of snowfall. Uh-oh, starting to pump fake, still showing it, but now kind of backing off. Look at the latest one, really backed off. This has got a lot of people nervous, right? Nah, it's still a ways out. There's a lot of uncertainty. There's a lot of inconsistency too. So the best thing to do when you're doing this is you look at what are called ensembles. Now, ensemble forecasts take a lot of different members, and here's the deal. If you're going to flip a coin, all right, let's put it this way. And it's halftime too, so you're not missing anything with the game. But put it this way. If you flip a coin, you're either going to have heads or tails, right? So you have, let's say you call for heads, and it's heads. That's one flip of the coin. That's one guess that's correct. Now, if I flip the coin again, is it going to be heads again? Maybe. But it most likely will probably not be over like 3 or 4 times. So you're not going to have heads 4 or 5 times. You can, but you most likely won't. But it's better to say, hey, I'm going to flip a coin 50 times, and let's see which one happens more. So this is called an ensemble. Ensemble forecasts are really essentially helpful because they kind of tell you probability. Probability is the way that people need to go with winter weather, but they don't. They don't, probably because it's a little bit more difficult to understand. But here's what I'm going to do. I'm going to show you this. So we're going to share this tab instead. This is the European ensembles, all right? We're going to zoom in a little bit just to show you that this is called the probability of 3 inches of snow or more. So obviously nothing by Friday morning. There's absolutely 0 on the board. But here we go. Now we're starting to see that probability. And honestly, this far out, that's pretty impressive. What are those probabilities? 70 to 80%. So the European is pretty confident that there's going to be over 3 inches of snow, especially in Oklahoma. But it all depends on the track. And look, this could continue all the way through Sunday with snow falling, which the GFS doesn't have anything Sunday. It's long gone. It has temperatures going back to 40 degrees. I don't buy that at all. What about 6 inches? Well, notice the probability drops down quite a bit. And for good reason, because that's more or less uncertain. Here is a look at the GFS probabilities, which are just basically trash. So I'll show you. We'll go to the GFS ensembles. And look at this probability. Let's do 3 inches. 3 inches is way less. So the GFS, this is why we have the basically the underlying uncertainty. Look, 20, 30%. No way to know exactly what's happening there. And so there's just so much uncertainty with that. We got one more thing to show you, and I'm going to shut down this Facebook Live because, there's just so much I could tell you this far out. Can't tell you to keep a watch of it. But we're going to look at something called winter storm severity impacts. So just to put this plainly, here, we're going to show you all those probabilities again. But here's a look at the probabilities of going back here. So, for instance, European. We're going to look at European ensemble. Here's your probabilities. There's the snowfall. We'll go 3 inches. Looking pretty confident. We're talking 70 to 80% probability. And maybe even 80, 90%. Like that's pretty high this far out to have that kind of probability of snow. Now, if you're farther north, boy, the snow drops off. That's because of the track of the system. That's why the track is so important. You look at 6 inches and that probability drops off pretty significantly. We're looking at around 30 to 40 to 50%. So this is probability of 6 inches or more. And this is all from the ensemble forecasts. 12 inches, look at the probabilities for that. Even with what it's showing on the deterministic, it shows 10 to 20%. So it's there, but it's not quite certain. But yet, all the people that are showing those deterministic models, they're basically saying this is going to happen 100%, whereas the ensembles are saying 10 to 20%. Now you tell me if that's really a a confident forecast. No, it's not. Let's go back to the GFS. And GFS ensemble obviously has less precipitation. It's going to be a lot less in terms of the snowfall. But we do know that snow is looking likely on both of them. So the ensembles are there. Last thing I want to show you is going to be this. This is going to be the winter storm severity index. Basically, let's start off with minor. So minor impacts, we're going to zoom in here on Northwest Arkansas as well as the surrounding area in case you're wondering about travel, and I'll get to some comments to close it out. But we're looking at right here, this is valid basically 2 a.m. Saturday, and there you get to see, we start to see some impacts. Now look at this. We're talking pretty likelihood of impact of minor impacts. Minor impacts, expect a few inconveniences. Winter driving conditions will be tough. Use caution while driving. And look, you can see that's getting up to 90, 95%. So we're pretty confident that winter weather is going to be a factor Saturday, especially Saturday evening, and it's going to be widespread all across the Mid-South. So be aware of that. Moderate impacts is where you can expect disruptions to daily life, but hazardous driving conditions, closures, and disruptions to infrastructure may occur. And you can see that that probability starts to drop off because, let's just face it, moderate impacts are less frequent. And so we're looking at 50 to 60%, and that's basically in Northeast Arkansas. So, Northeast Oklahoma, excuse me. If you're going to Tulsa, I know some people are, I think there is a PBR bull riding competition that's happening in Tulsa, and that's Friday. That's going to be trouble. Maybe not so much Friday because there's not as much stuff going on, but driving back home on Saturday might be getting a little bit difficult as that snow comes in. Major impacts, well, still a likelihood of 20 to 30%, but it's not as likely. And so that's going to be something to watch. And then extreme, it's showing the potential very, very small, 5%. Now, the farther out in time, or further out in time, if you will, the closer we're going to get to the system, the more information we're going to have. And that's why we're just going to basically break it all down for you. So there's a lot of uncertainty, but we'll continue to watch. Show Georgia, please. Okay. I just saw that on the comments. I can. I'll zoom out for you in case you're watching area wide. First of all, appreciate it. We'll go back to moderate impacts. And Georgia, it looks like mainly northern Georgia is going to be getting the impacts of that. That's moderate impacts. So now keep in mind, different impacts for different areas. Minor impacts, which is, considering northern Georgia doesn't get as much snow usually, that's going to be significant. This is all happening again Saturday morning into the afternoon is when that storm really hits. Now, beyond that, I just want to mention that we also have very, very cold air that we're going to be dealing with that system. So a lot to discuss, but basically to sum this up in about 2 minutes, all right, and then I'm going to shut this down, is number one, Northern Lights doesn't look to be happening with the naked eye. Might catch it with the camera. Solar storm was pretty strong, but it wasn't clicking, if you will. Literally the magnetic field not clinking. You can look at the BZ and you can check that out. That is a winter storm severity index probability. It's on the weather prediction site. So it's a really good site to check that out. But keep in mind that changes quite often. So as we get to 3 days out, we're going to have a better idea of the winter storm severity index, the probability of a winter storm index, all that stuff. That's, remember, 1 to 3 days out. That's when we get the details. And even then, it's still absolutely not perfect. Number two is the winter storm is coming Friday into Saturday. We're pretty confident on that. Winter precipitation is looking likely. At this point, I think it is going to be all snow, but I don't think it's all snow everywhere. I think there's going to be a little bit of a wintry mix in the initial start, but as of now, it does not favor a big icing event for us. Now, that could change depending on that system and how it moves in. And then as we go into basically our Saturday, that's when the most likely time for accumulating snow will be. I do think this will be several inches of snow. I'm not sold on, the exorbitant amounts that the European are putting out. But we aren't going to really talk about accumulation. At least I'm not. Other people can. That's fine with them. They can put it out. They're probably not going to be accurate that far out, or maybe they just basically were a blind squirrel that found an acorn or a nut, essentially. So too far out to predict totals, won't likely know until Thursday, Friday. Exactly. That's because the system will be moving in. Got the ice baby. That's going to be for northern Louisiana. I really do think northern Texas, northern Louisiana has to watch out for a significant ice storm. This absolutely has the making of it. But remember, there's all those Baja blasts, all those fine scale features. The GFS is way off. It's too quick. It's too dry. Not enough precipitation. It doesn't handle that low, in my opinion, and it kicks it out without a kicker system. That doesn't make sense. And then on top of that, it keeps it to the southwest. So why is it pushing it south? It just doesn't mesh. We'll see what happens, though. That model could be right. So as far as everything else is concerned, I do want to let you know that I do have a weather blog that Aleshli wrote. It's on our website. It's got much more information and breaks it down for someone that maybe, is wondering what's going on, and you can share it with them. That is going to be on our website here. Let me bring that up. In fact, here's what I'll do. I'll bring up the website now and show you where it's at. Let's see here. Okay. Go here, show this tab instead. Make sure that's up. It's not. Okay, so here's the winter, there's the weather blog. Major winter storm expected. It's got all the information in there. It's got precipitation amounts, talks about snow, it talks about uncertainty. So there's still a ways out with this system, but that is Aleshli's weather blog that she put together, and that'll keep you updated. We'll continue to keep you updated on that as well as online, social media. But as of now, I'm not going to post every single computer model run. Just not that kind of person. If others do that, the hat's off to them. Is there a window of total inches of snow? What is the least amount? 0 inches. Honestly, winter weather is finicky. It's finicky as can be. So it could be 0 to as much as over 10. that's the best we can do, honestly. But cold does come in, and we're talking some significant, substantial cold. In fact, just to break down the complexity of this system, I'll show you one more thing here, and then we're going to shut it down. So this is the hazardous weather outlook. So we've got multiple things that are overlapping from the Weather Prediction Center. Hazardous cold, January 24th to the 25th. That's Saturday through Sunday. You've got heavy snow Friday through Saturday. I think that could go, well, really most of the snow will be Saturday. Freezing rain Friday through Saturday. Hazardous cold down here. This is basically one big polygon, January 25th to the 26th. Then beyond that, you got some really cold. That's an accurate I said 10 plus too, Jennifer. So my wife is on here. If I go 10 plus, then we basically nailed it, 0 to 10. Now, I think honestly, 4 to 8 is a good range. 4 to 8 plus as of now. That's not my initial. That's not my forecast, but that's just basically what I think. So substantial amount of snow, snowpack effects, really cold temperatures, pipe bursting weather as we get down to 0 and below 0, and possibly long, prolonged period of being below freezing. So that's trouble in terms of cold. Northern Lights viewing potential, not looking as likely. One last look, and the reason for that is our BZ is just not pointed south, and that makes a huge difference in if you can see the Northern Lights. And really a strong storm, but man, it hit hard, but that was about it. Here you look right here. You see that red line up at the top of the screen? It's way up there, and it just hasn't flipped at all. And now it's slowly coming back down to 0. Just shows you that space weather is just as difficult to predict as a winter weather or any type of weather for that matter. So, but this is definitely a big winter system that's coming. We'll be watching it. We'll keep you updated. Yes, the euro is going nuts, but remember, Bradley, we showed you the trends. That just dramatically happened over the last few model runs. So there's not a trend yet, but it is something to watch for sure. Florida is going to be cold too. Never too late for that, babe. Let's go ahead and do it. Let's get to the Bahamas and miss all this stuff. For all y'all wishing for snow, here you go. You're going to get your wish, it looks like. And there's going to be a lot of problems, a lot of accidents, a lot of people, just spinning out all over the road. Fun stuff. So yeah, just to show you, this is the magnetic field right here. What happens when it repels? They don't click. It just doesn't happen. That's exactly what is happening right now. But that's what would happen if we had a southward pointing charged plasma cloud. We didn't, so you don't know which way it's going to be pointing. All right, guys, take care. Enjoy the rest of the second half. I'll be on Fox 24 at 9 and KNWA at 10. No live update after the 10 o'clock tonight, even though new model data is going to be coming out. I've got to MC a cancer challenge event, and it's at 7 a.m. tomorrow, and I got to work the 10 o'clock. So got to get some sleep, and we'll catch you guys later. God bless. Have a good one. As always, keep you here with your weather authority. We'll keep you updated on the winter situation.